Good day everyone, my name is Princess Campaner and today our group is incredibly proud to present to you guys our final project in Comprog, a basic Java programming entitled Pixel Cottage Cafe Ordering System.
Before we start, let me introduce our team, the Powerpuffgurls, headed by Princess Campaner Nex, Chris Janice Delia, and Hazel Ann Fabroa.
So before we jump directly into technical source code, let us discuss the concepts, purpose, and objectives behind this application. In the modern food and beverage industry, efficient data handling and user interaction are crucial. Small local bricks and mortar coffee shops often face operational bottlenecks when relying on manual handwritten or confusing outdated command line interfaces. Manual processes frequently lead to misread orders, inaccurate billing calculations, and zero data tracking.
Structural architecture and visual component walkthrough. Now let us examine how the visual framework of the application is constructed. Our main class, Pixel Cottage Cafe, extends the standard Java Swing class JFrame. By inheriting from JFrame, our class gains all the capabilities of a standard desktop window. Inside our constructor method, which sits on lines 12 through 14 of our code, we explicitly set up our window parameters. The title is set to Pixel Cottage Cafe, the width is set to 1300 pixels, the height is set to 760 pixels, and it is centered perfectly on the monitor using set location relative to null. To organize our components without a messy layout, we utilize a border layout with 15 horizontal and vertical gaps. A border layout divides our window into 5 distinct regions: North, South, East, West, and Center. The header, which is in the North region, handled by the creator header method. It groups our main title and subtitle inside a vertical box layout nested within a grid bag layout to ensure perfect alignment. The menu panel, center region, this is where the core of our user interaction happens. It displays all available food and drink choices, grouped neatly into categories. We wrap this panel inside a J-scroll pane. This guarantees that if our menu grows in the future, users can vertically scroll through items effortlessly without breaking the interface bounds. The cart panel in East region, positioned on the right side of the screen with a fixed width of 330 pixels. It acts as a sidebar containing our non-editable JText area for order logs, a live total cost counter, and primary execution button labeled Place Order.
Let us now discuss the most critical technical objective of this programming project. It is the implementation and application of arrays. In professional enterprise system, minute data is typically pulled from external relational databases. However, because our objective is to master the fundamentals of core Java data structures, we design a self-contained data architecture utilizing 4 parallel linear arrays. You can find this declared as global constant from line 5 to 10 of our source code. Let's break down exactly what these arrays and how they operate together. First, we have categories, an array of string that maps the organizational sections. Second, we have the item names, an array of strings storing the actual customer-facing product names. Third, we have an item prices, an array of primitive double data type that holds the cost values for our math operations. Fourth, we have the item image, an array of string holding the local relative directory file paths to our graphical PNG image assets. The term parallel arrays means that even though these are 4 entirely distinct structures allocated separately in your computer's memory, they are completely synchronized by the tracking index number, which we will represent with a variable I. Let's trace a practical example to make this completely clear. If we look at the index number 0 across all 4 arrays, simultaneously, categories 0 gives us hot coffee. Item name 0 gives us espresso. Item prices 0 gives us 120, the price. Item image 0 gives us the image or the PNG. If we jump over to index number 11, categories 11 gives us desserts. Items names gives us croissant. Item prices 11 gives us the exact amount or 95. Item image gives us the image, the PNG. By structural design, if we add, remove, or modify an item, we must update all 4 arrays at the exact same index position. This parallel configuration allows us to easily maintain, read, and manipulate multiple attributes object data using simple primitive array structures.
Let's move on with the event loops and rendering.
Main event loop is the desktop application enters the active listening loop, keeping standard swing UI frame responsive and open that can trigger the click add to cart event listeners triggers lambda callback, capturing matching properties using active array indexes. And the action of it is the dynamic update, which appends item details directly to list and the increments calculations before returning to the standby loop. And this is the automatic cycle. Next is the bypassing of lambda constraints, and it is the Java action events with loops requires variables to be effectively final. We initiate a local score helper int index equals I and directly inside the inner loop prior to registering action clicks, preventing the scope leakage.
The next is the scope resolution that implemented nested block pointers to encapsulate variable references safely within the dynamic click triggers. The next one is the state management. Seamlessly manage the transitions between catalog parallel data, client list, and clean system state waves upon receipt creation. And the last one is the precision math. It's reconciled primitive floating totals accurately, avoiding standards double presentation transaction inside total calculators.